Okay, let's go ahead and look at the notes here. We've got a few more pages to finish, so that way we can be done. Next part here they want to talk about is net forces that are being used with free body diagram. Okay, so now we're going to start talking about what happens when there's actually a magnitude with that vector arrow and how you solve for those. Okay, so let's look at this. Let's get the blanks filled in. It says here that the net forces is the vector sum of all of the forces acting on that object. Now we're no longer just talking about up and down or right and left or up and to the right. Okay, now we're talking about 4 forces or 5 forces or 6 forces, all of them at the same time acting on one object. It says here that the net force of the sum of all the forces, taking into account the fact that a force is a vector and 2 forces that are equal in magnitude and that are opposite, right? This is what we already know. Directions will definitely cancel each other out. It also says here, if given a description of a physical situation, begin by using the understanding of the forces or the force types to identify each of the forces that are present. Okay, they're just kind of giving you a small description on how you're going to do it, but we are definitely going to practice over here. Then determine the direction in which the forces or the force is acting. Draw a box or the object, and all of this will make sense in just a moment. And add the arrows, right, our vector arrows, for each existing force in the appropriate direction, as well as you must label each of those arrows and identify the actual type of force it is. What type of vector are we talking about? Next part here says find the net force in the X and the Y direction, okay, and determine the direction and the net force of the net force using SOHCAHTOA. Yes, I told you it was going to come back. SOHCAHTOA. So, right, when we're talking about direction, we're talking about the theta or the angle, and we are going to have to need SOHCAHTOA to help us in this case. Okay, not all of them, but the majority of them we will be doing SOHCAHTOA. So let's go ahead and let's talk about how we actually do this. The following free body diagram is already drawn here for you to the side. It represents forces that are acting on a hot air balloon. Okay. First thing, step number 1. Right now, here, this is steps. We are baby stepping how to do the problems like this. We will eventually probably just get words and not even a picture, or we'll just get a picture and no words, okay? And they're not going to do it step by step. You're going to have to do those steps. So they gave us the actual picture. Not only do we have the arrows, but we have the magnitude or that number that goes along with the arrows. Step number 1. The first step you should do is probably go ahead and find the net horizontal force. When we say net force, we want to find the answer. Horizontally, what's going to happen. Step 2, we want to find the net vertical force. So vertically, what's going to happen, up or down? Are they going to cancel themselves out? Are they going to move up? Are they going to move down? What's going on? And then step 3, we need to find the net overall force acting on that object. Like overall, what's going to happen. Okay? So let's go ahead and do that. First thing, when we're talking about horizontal force, remember we're talking about the X direction or the X component. Okay? And in this case, Let's look at the X. The X is horizontal, so that would be here and here. That is the X. I've got two arrows that are in opposite direction. What am I going to do? I'm going to subtract them. Do I care about negatives? No, I do not. So don't give me a negative value. Give me the difference between those two numbers. So in this case, I'm going to go ahead and, just so I don't get a negative number, I'm going to use the bigger number first. 1520 newtons, take away 950 newtons. Okay? So 1520 take away 950 equals 570 newtons. Again, we're talking about the X component or the X direction. Now let's go back over here to those two arrows. There's a 950 and a 1520. Which one of those two vectors is a stronger arrow? What result is my object going to move overall? If I'm only looking at the horizontal, it's going to move over here towards this way, the left. Okay, so I'm going to go put, just for myself, I'm going to put left. That's not my answer. This is helping me guide towards my answer. Now it says go ahead and find the net or the answer vertically. So let's look at it right here vertically. This right here equals the Y component. I've got an arrow here and an arrow here, and they are in opposite directions. What do I do again? I'm going to subtract them. I do not want a negative value. So for me personally, I like to look and use the bigger value first so I don't have a negative answer. So let's go ahead and put that in. 5120 take away 4050 equals an answer of 1070 newtons. Okay, let's go back to the picture. Which vector is stronger or bigger? Up. So my answer is going to move up. The up direction vertically wins over the down. Okay, again, this is not my answer. This is what's going on horizontally. This is what's going on vertically. Now, we need to find the overall net force, okay, acting on this balloon. And when they're asking for that, because I have it up and down, originally I started with 4 forces. I narrowed it down to 2 directions. Look, 1, 2, 3, 4 directions. I narrowed it to 2 directions, okay? So here's what I like to do for me. I'm going to come over here and I'm going to write a little graph, do an X and Y. Right? Here's my X and here's my Y. And in the X direction, my graph or my vector arrow is going to be 570 newtons to the left. 570 newtons. Now, vertically, I can see what I have over here. It's going to move up 1070 newtons. So I'm going to draw it up, and I'm going to say 1070 newtons. Okay? What do I see? Oh, snap. I see that I'm ending up with some type of little, let's go ahead and I've got something going on over here. I see a right angle. Okay. So what am I going to do with my right angle? I'm going to go ahead and I'm going to